All right, now we're going to graph some of this. So if we have net this time, whenever we are presented with a graph, we have to look at the axis to see what information we're even dealing with. So the net force on the girl does this little thing and then jumps up to 40. So the net force on the boy goes here, right? And then equal magnitude, opposite direction. Equal magnitude, so the magnitude would be 40, and it goes all the way to the 4.5 seconds. And then up here, we finish off here. Equal in magnitude and opposite in direction. That's what it looks like on a graph. Girl's velocity is increasing, so she has positive acceleration. The boy is going to accelerate in the opposite direction, because remember, they're pushing off of each other. So one is going to accelerate to the right and one's going to accelerate to the left. What does acceleration to the left look like? It looks like acceleration in the opposite direction. That was bad, so I had to cut and start over. So there's that. And then for the last piece here, we're going to... But Mr. Scopetis, those are not the same magnitudes of acceleration, are they? They're not. It is half of the final velocity, right? If you'll see, the magnitude of the girl's velocity is 4 here. So it's half of that, because in the problem you may have to look up, the boy's mass is twice the girl's mass. And remember, acceleration is inversely proportional to mass. So if we double the mass over here, then that's going to just be half the acceleration on the left side. All right, continuing on. We have a student starting from rest begins to walk forward. Consider the student while they are taking their first step forward. Action. When you walk, or when this person walks, you are exerting a frictional force, not fictional, frictional force backwards on the floor. So if you think about it, take your shoe when you're standing. As you walk, and here's the ground, you are pushing that direction backwards into the floor. That's what's going to allow you to move forward. Right? You don't just glide across, you don't do this up and down. You have to bend your toes, right? And that bending of the toes directs the force down into the floor. Okay, well, what does that mean for the reaction? That means the floor, and therefore Earth, accelerate backwards because you're pushing on them backwards. So the reaction of that is the floor is going to push back on you. Let's get a different color here. So that way. The floor pushes forward with a frictional force, because remember, it has to be the same type of force. And the reaction is the person, you, accelerates forwards. I should have really used the typing thing. I know, stop yelling at me. All right. You push down on the floor in that direction. Floor is going to push back on you in this direction. Forward. Here you are in high school, and a lot of you just learned how to walk.